Good morning or afternoon or evening. I hope your spring break is going fantastic. Here's the third video in our sequence. You should have just spent a little bit of time refreshing on some rules of simplifying radicals as well as rationalizing the denominator. That's going to be helpful little reminders moving forward through this lesson. So today we're going to look at how to evaluate inverse trig functions. Okay, so what we did in the lesson before was evaluate standard trig functions like y equals sine of x, y equals cosine of x. And so when we were evaluating those functions, like y equals sine of 30 degrees, right? And what we'd get out of that, thinking about maybe our unit circle is 1/2, right? So 1/2 is what sine of 30 degrees equals, okay? And so just as a reminder, when we're dealing with regular trig functions, okay, when you put in something, right, your x value, what you're putting into it, or your theta, we've been using theta, is an angle, okay? When you put something inside of a regular trig function, it's an angle, okay? And what comes out of it is a ratio of sides. This is your output. This is like your y, okay? This is ratio of sides, okay? So when we're thinking about inverse trig functions, remember, when we're thinking about inverse functions in general, we always just switch our x's and y's, right? That's our thought. And so think about it as now, when we're dealing with inverse trig functions, okay, inverse trig functions look like this. Y equals inverse sine of x. Y equals inverse cosine of x. Y equals inverse tangent of x. Okay. What you're putting into any inverse trig function always, what goes inside of it now, is a ratio of sides. Okay. And so intuitively, what do you think is going to come out of it when you put in a ratio of sides? What's going to come out of it is, I'm just going to get rid of that so we don't get confused here, is going to be an angle. Okay. And that's going to be really helpful to ground our thinking. So here are 3 of the inverse trig functions. But there are 6. Just like there are 6, because the only way to undo sine, cosine, and such is to do the inverse sine. Now, this is a different notation. Arc sine is the exact same thing as inverse sine of x, okay? So these are the exact same thing. They're just 2 different ways to write it. Same thing, this is the same as inverse cosine. This is the same thing as inverse tangent. This is the same as inverse cosecant. This is the same as inverse secant. And this is the same as inverse cotangent. Okay. So these are what our functions look like, right? Again, what you're putting in is a ratio of sides. What comes out of it is an angle, okay? All right, so let's take a look first at how we can approximate inverse trig functions. How do we do this? And when we're approximating, we're just going to use our calculators, okay? So make sure that your calculator is in the right mode. Now, it's kind of hard to tell here, and I should have been more specific. So I'm going to go ahead and say, let's just work in degree mode. It should have specified, and that's my fault. Okay, so what you notice here is you've got sine of some angle equals some ratio of sides. Right? You don't know what type of ratio of sides, but it's some ratio of sides. Now, the only way to get rid of this sine and free up b, and you want to solve for b, is to isolate b. You have to undo sine, but the only way you can undo sine, just like the only way you can undo multiplication or undo addition, is by using the inverse operation. Okay, well, the inverse operation for multiplication is division. Addition, it's subtraction, right? For sine, it's inverse sine. Okay, So we need to actually go ahead and take the inverse sine of this side. Now again, what you do to one side, you have to do to the other. You've got to balance them out, right? So I'm also going to take the inverse sine of this side. Okay. What you'll notice here is that the sines cancel, and you're left with b, which is some angle, equals the inverse sine of 0.4848. Okay. Oh, it did say degree, but still. Now, what do you see we have? We've got an inverse trig function, a ratio of sides inside, some decimal, and what is going to come out of this is an angle. Okay, so that stays consistent with our idea of inputs being a ratio of sides, output being an angle. Okay, let me just show you here how we calculate this. Hope you can see it. Can you see it? Okay. So our inverse functions here, if you hit second sine, what you'll see right here is that you've got your inverse sine that pops up, right? Okay, so I just hit, again, second, and then the sine button, and that pops up, right? And then I'm going to put 0.4848. Okay, I'm going to hit enter. Now, if this is not the number you're getting, it's because you are not in degree mode. So make sure you hit mode and confirm you're in degree mode. Okay. Now it says round to the nearest degree, so I'm going to go with 30 degrees, which makes sense because we know that sine of 30 degrees is 0.5. So that kind of makes sense. So I'm going to round to 30 degrees. Okay. Now you don't have to show me the work each time here that you do taking the inverse sine when it's all by itself like this. It's just helpful to remember. Either way, we're going to find A. It's going to be the inverse sine of that, and that'll be some number. W will be the inverse cosine. That'll be some number. And same thing, A. Okay. And this will be some number. And you can get the answers. That'll be good, a little bit of practice, right? Except the only issue with this is, first off, these aren't exact answers. So really these should all be squiggly approximations. Okay? They're not exact answers. And the other thing is, your calculator is only smart enough, it has a restricted domain. All right, which means that some of the solutions, there's actually an infinite amount of solutions here, because you can go around the circle as many times as you want, right? So this here is you're actually missing some solutions, okay? And so we need to go through and use our unit circle, because approximating inverse trig functions, it's fine, but it's not going to give you all the answers that you need, okay? So we're going to take a look at how to do that. Okay, so again, this is how we're going to find exact values for inverse trig functions. Okay, we talked about this, right? Inverse, the inputs are a ratio of sides, the outputs are angles, radians or degrees. Okay, so again, arc sine of 1/2. This is a question. I'm asking you, what is arc sine of 0.5? Okay. Another way of seeing this could be the inverse sine of 1/2. These are the exact same thing. Okay. Now, essentially what we're doing is we're using the unit circle in a similar way, except we're doing it in the other direction. So instead of looking at the angle and trying to figure out a ratio of sides, what we're doing is we're putting in a ratio of sides and looking for an angle. Okay. So if I'm looking for arc sine of 1/2, I'm looking for sine, right? So I'm looking at the y values. Okay. And I'm looking for a y value of 1/2. Okay, well, here are the y values. Here's 1, right? what angle is associated with that 1/2? 30 degrees. Okay, that's one of our answers. Now I say 1 because keep looking. No, y value, there it is. Sine of 150 degrees will also give you a ratio of sides of 1/2, which means when you take the inverse sine of 1/2, you can either get 150 or you can get 30 degrees. And again, your calculator, say I do inverse sine of 0.5, your calculator is only going to give you one of the two solutions. Okay, and that's just not good enough. So, in this case, our solution here is 30 degrees and 150 degrees. Okay. All right, so I'm going to go through a couple more examples here before you're off to practice. Okay, it's asking for the exact value. I should never be getting decimal approximations here because they're not just going to ask you to use your calculator. So, we're looking for arc sine of -1/2. Okay. I'm going to get a unit circle here so we can have something to look at. I'm looking at my y values because it's sine, right? And then I'm looking for a -1/2 y value. Okay, so if we look on our unit circle, y value of -1/2. And again, it's going to happen twice. Here's one of them. That happens at, does it say radians? Okay. We'll put it in radians. Why not? 7 pi over 6 is where it happens once. And then if you keep looking, there it is again. And those would be our two solutions. Now, I didn't specify, so if you wrote the degrees 210 or 330, that would be acceptable as well. Okay. All right, let's look at the next one. Inverse sine of √3/2. Okay, well, again, y values, we're looking for √3/2. And the angles associated with that will be our answer. Because we're putting in ratio of sides, we should be getting out an angle. So, y value √3/2, here's one of them, 60 degrees. And here's the other one, 120 degrees. Now again, you could have written pi over 3 and 2 pi over 3. That would have been fine as well, right? All right, and then again, we're doing the same thing here. Sine, inverse sine of 2. Okay, well, we're still looking at y values, but the issue is here, 2 doesn't fall on the unit circle, right? So in some cases, what that means is this is just out of the domain, okay? But if you think about what a sine graph looks like, and we're going to do graphs of sine in more detail later, sine goes from 1 to -1, okay? So really this is no solution because it's out of the domain of our sine function. Okay. Alrighty. Okay. All right, you guys are all set to do your practice for this section. Good luck.